Timber has re-emerged as a favored material in modern construction due to its natural aesthetics, sustainability, and excellent strength-to-weight ratio. However, its combustibility remains a major concern in structural fire design. To address this, engineers often adopt conservative methods, the most common of which is over-dimensioning timber elements to compensate for potential fire-induced degradation. This practice, largely based on standard charring rates, is intended to ensure that the structural performance of timber members is maintained during a fire. While effective in enhancing safety, this approach can lead to inefficiencies in material use and therefore increased construction costs. In this video, we'll explore the charring behavior of timber, how over-dimensioning works in practice, and some criticism and limitations surrounding it. At the end of the video, we will also go over an infographic which shows over-dimensioning in practice. When timber is exposed to fire, its surface chars, forming a protective layer that insulates the unburned core and slows further combustion. The speed at which charring progresses into the timber over time is known as the charring rate, and is a key variable in fire resistance design. Standardized testing has shown typical charring rates for softwoods to range between 0.65 and 0.80 mm per minute under standard fire conditions. Structural design codes such as Eurocode 5 and the National Design Specification, or NDS, incorporate these rates to estimate the reduction in effective cross-section over time. The residual or uncharred section must retain sufficient strength to support loads during and after fire exposure. To meet these criteria, designers often over-dimension timber members beyond what is necessary under normal conditions. Over-dimensioning refers to the intentional increase in the size of timber elements to account for expected material loss due to a fire. This practice is based on simple, conservative assumptions that favor safety over optimization. Designers may increase member dimensions to achieve specific fire resistance ratings, comply with prescriptive code requirements, or provide a safety margin in the face of uncertainties in fire behavior. Often, worst-case scenarios are assumed, including maximum charring rates, uniform exposure, and full fire duration without suppression. While this ensures a high level of fire resilience, it also leads to structures with significantly more material than needed for non-fire, load-bearing purposes. While over-dimensioning improves fire safety, it comes with several notable limitations. The approach is rooted in conservative assumptions that may not accurately reflect real fire scenarios. Design codes often rely on standardized charring rates and continuous fire exposure, assuming uniform burning across the timber surface. However, actual fires are influenced by factors such as fuel load, ventilation, suppression systems, and compartment geometry, all of which can lead to lower or uneven charring rates in practice. Another limitation lies in the treatment of the charred layer. It is typically considered entirely non-structural, but research suggests that in some cases, especially with large cross-sections, charred timber may still contribute to the member's load-bearing capacity, at least partially. Moreover, the method does not account for the potential of advanced fire protection systems or innovative materials, which could enable more efficient and less material-intensive designs. There are also environmental concerns. Overuse of timber for fire resistance can reduce the sustainability benefits of timber construction by increasing material consumption, even though timber sequesters carbon. In engineered wood products like cross-laminated timber, Glue lines between layers can further complicate fire performance. These adhesives may influence charring behavior or introduce weak planes, potentially affecting the structural integrity of the residual section during a fire. The infographic shown right now visually represents the concept of over-dimensioning. It compares the effect of different charring rates and fire durations on three common structural elements: walls, columns, and beams. The black outlines show the original structural size, while the colored dashed and continuous lines indicate how much of the material would be lost to charring at specific rates and times. Two typical charring rates are considered: 0.5 mm per minute and 1.0 mm per minute, with fire exposure durations ranging from 30 to 120 minutes. This corresponds to the slowest and fastest design charring rates for different wood products according to Eurocode 5, Table 3.1. For walls, charring occurs on two exposed faces. At the lower rate of 0.5 mm per minute, a 30-minute fire results in 15 mm of char depth on each side. For a 120-minute fire, this increases to 60 mm. At the higher rate of 1.0 mm per minute, the char depth doubles, reaching up to 120 mm per face over 2 hours. Columns, which are exposed on all sides, require even greater consideration. Because they carry axial loads and have all-around exposure, the charring depth must be accounted for on each face. The infographic shows how significantly the effective cross-section reduces over time. A 90-minute fire at a rate of 0.5 mm per minute leads to 45 mm of loss on every face. Over time, without proper sizing, this reduction would severely compromise the column's ability to carry vertical loads. Beams, typically exposed on three sides, present another unique challenge. The bottom and both vertical sides char simultaneously, reducing both the height and width of the beam. At 60 minutes and 1.0 mm per minute, 60 mm of material is lost on each exposed face. The structural core must be wide and deep enough to retain bending strength and stiffness after charring. Over-dimensioning is a common and reliable way to make timber structures safer in a fire, by increasing the size of members to allow for charring. While this method is simple and effective, it often results in using more material than necessary, which can increase costs and doesn't work well with sustainability philosophies. As we know, real fires don't always behave like the standard assumptions used in design codes. Factors like fuel load, ventilation, and suppression systems can change how timber chars. In some cases, the charred layer may still offer some strength, and modern fire protection methods could reduce the need for large safety margins. If you enjoyed this video, take a look at this video about the fire resistance classes or this video about the reaction to fire classes. Stay informed, stay inspired. TimberTalk.